Welcome to this lesson on the Maclaurin series expansion of e to the x. Our goal today is to expand the function e to the x into an infinite series using the Maclaurin series. Let's recall what the Maclaurin series is. The Maclaurin series is a special case of the Taylor series centered at x equals 0. For any function f of x, it's given by the sum of the function's derivatives at 0 times x to the n divided by n factorial. For e to the x, something special happens. When we take derivatives of e to the x, we keep getting e to the x back. Let's look at the first few derivatives. When we evaluate these at x equals 0, we get f of 0 equals 1, f prime of 0 equals 1, f double prime of 0 equals 1, and so on, all derivatives evaluated at 0 equal 1. Therefore, our Maclaurin series becomes e to the x equals the sum from n equals 0 to infinity of x to the n divided by n factorial. Let's write out the first few terms. When n equals 0, we get 1. When n equals 1, we get x over 1 factorial, which is just x. When n equals 2, we get x squared over 2 factorial. When n equals 3, we get x cubed over 3 factorial, and so on. Simplifying the factorials, we get e to the x equals 1 plus x squared over 2 plus x cubed over 6 plus x to the fourth over 24, and so on. Let's visualize how these terms contribute to the function e to the x. Notice how each additional term improves our approximation of e to the x. The more terms we include, the better our approximation becomes. This series converges to e to the x for all real values of x, making it a powerful tool in calculus and mathematical analysis.